In this video, I'm going to talk how can we solve for current, voltage, and resistance for series and parallel circuits. To answer a question about these three variables, we must know and apply Ohm's law and the rules for finding current, voltage, and resistance. What is Ohm's law? Ohm's law describes the relationships between voltage, current, and resistance. Voltage and current are proportional to each other, which means if the current is increases, then voltage will increase. If the voltage is increasing here, then current will increase. Current and resistance are related inversely, which means if resistance is increasing, then current will decrease. For memorizing the formulas, you can use the Ohm's triangle here. Put V at the top and current and resistance below. If current and resistance is given, then you can solve for V multiplying I times R. If V and R are given, then you can solve for I equal V divided by R. See the division sign here. And if V and I are given and you are required to solve for R equal V divided by I. Now let's go and see solving series circuits. Before solving this circuit here, we need to recall that in a series circuit, which is one path for electrons to flow through, total current is equal everywhere in the circuit. So I total equal I1 equal I2 equal I3. Voltage drops because it's used by the loads resistor. So total voltage is equal V1 plus V2 plus V3. And total resistance is R1 plus R2 plus R3. Now use a circuit to answer the question, then fill out the table above. Calculate the total resistance in the circuit. That's easy because individual resistances are given, 25 plus 15 plus 20, 60. What else is given? Voltage, 12 volts is provided. Second question is calculate the current in the circuit. We are using now the Ohm's law, V equal I times R. Voltage is 12. I is required, resistance is 60, total resistance. We divide both sides by 60 and we find the total current 0.2 amperes. So current is 0.2 in each of the resistors. Now question 3 is calculate the potential difference across the three resistors. So again, we're using the Ohm's law, V equal I times R. V1, current is 0.2, we found that, times 25, which is the resistance for the first resistor. And when you multiply, you get 5 volts. For second resistor, the same way, multiply the total current by the resistance, which is 15, you get 3 volts. And for the third resistor, you have 0.2 times 20 is 4 volts. When you add this together now, you'll get 12. So using your answer, verify that Vt equal V1 plus V2 plus V3. We just proved that. Now let's go to solving parallel circuits. To solve parallel circuits, we need to recall that there are more than one path for electrons to flow in this parallel circuit here. Total current is I1 plus I2 plus I3. So there is more than one way for the electrons to pass through the circuit. So current is divided between branches. Total voltage is equal V1 equal V2 equal V3. Total resistance is 1 over RT equal 1 over R1 plus 1 over R2 plus 1 over R3. And this is inverse because when the resistance is increased, the current decreases. Now let's go and solve for this circuit here. Use the circuit to answer the following question. What is the total resistance of the circuit? 1 over RT equal 1 over R1 plus 1 over R2 plus 1 over R3. And we plug in the known values here. 1 over RT, 1 over 5, the resistance for the first resistor, plus 1 over 10, plus 1 over 20. We add these three fractions and we get 1 over RT equals 7 over 20. Now be careful, this is not the value of the total resistance, it's the inverse. So we have a proportion here and you know how to solve a proportion. You cross multiply or use another method. So RT times 7 equal to 20 times 1. Then you divide both sides by 7 to isolate RT. And finally, RT is 2.86. Calculate the total current in this circuit is question 2. So we apply the Ohm's law, V equal I times R. Voltage is 20, is provided, is given. Current is required. The resistance is 2.86 ohms. We divide both sides by 2.86 and you get the total current 7 amperes. Next question is, what are the potential differences across the three resistors? This is obvious because in a parallel circuit, the voltage in each branch is equal to the voltage of the source of the battery here. So 20, 20, 20. Last question is calculate the current through each resistor. Again, V equal IR, voltage is 20, I is required, 5 is the resistance for the first branch. You calculate and you get the current is 4 amperes. For second one, the same formula, 20 equal to I times 10, and I2 is 2 amperes. For the third one, I3 is 1 ampere. Now, when you add up, you'll have to get 7, 4 plus 2, 6 plus 1, 7. So total current is 7, and we found it 7 here. Voltage, as I mentioned, is 20, 20, 20, 20. So this is one example how to solve parallel circuits. Thank you for watching the video.